You know, every single time you open an app on your phone, you're putting your trust in a whole lot of code you can't see. Well, today we're going to pull back the curtain on the critical process that actually earns that trust. Welcome to the world of software testing. Let's get into it. Now, what we're about to get into, this isn't just some theory I cooked up. This is the real deal. This entire explainer is built on the official syllabus from the ISTQB. That's the globally recognized standard for software testing that pretty much everyone in the industry uses. All right, here's the game plan. First, we'll cover why we even have to do this. Then, we're going to bust some common myths. After that, we'll dive into the 7 principles that guide all testing, look at a tester's day-to-day workflow, and finally, talk about the people who make it all happen. So let's start with the biggest question of all. Why bother testing? It seems kind of obvious, right? But the answer goes so much deeper than just fixing a few annoying glitches. The consequences of not testing can be, well, they can be huge. I mean, who hasn't, right? That feeling of frustration, we've all been there. But that little annoyance is just the tip of a very, very big iceberg. See, in the real world, software failures aren't just inconvenient, they're costly. Back in 2012, there was this trading firm, Knight Capital Group. A single software bug caused them to lose $440 million in 45 minutes. It almost bankrupted the entire company. So yeah, from losing money to ruining a company's reputation, or in some cases, even causing serious injury, testing is our first line of defense against absolute chaos. And to really understand the problem, you have to know the language. It all starts with a person making a simple mistake. That's the error. That error creates a problem in the code, which we call a defect or, a bug. Now, that bug just sits there quietly until you run the program and it suddenly crashes or does something weird. That visible mess up, that's the failure. The entire goal of testing is to find the defect before it gets a chance to cause a failure. Okay, so this brings us to some huge misconceptions about testing. A lot of people think it's just about, randomly clicking buttons and trying to break things, but it's a serious engineering discipline, and it's really important to know what it is and what it isn't. First off, testing is not the same as debugging. Here's a great way to think about it. The tester is the detective. They find the evidence and say, hey, something's wrong here. The developer who does the debugging, they're the forensic specialist. They analyze all the evidence to figure out exactly what happened and how to fix it. 2 totally different but equally vital roles. And another big one, testing is not quality assurance, or QA. This trips a lot of people up. Testing is what we call corrective. It's hands-on with the product, finding bugs that are already there. QA is bigger. It's about the whole process. QA is preventive. It's about setting things up so that bugs don't get created in the first place. So QA tries to prevent the fire, testing is putting out the flames. Okay, so if it's a real discipline, it's gotta have some rules, right? You bet. Let's get into the 7 core principles of testing. This is basically decades of wisdom all boiled down into a few key ideas. All right, number 1, and this one is so important. Testing can prove that bugs exist. It can never, ever prove that a system is 100% bug-free. You could run a million tests and find nothing, and all that means is you haven't found a bug yet. Second, exhaustive testing is impossible. I mean, literally. Think of a password field. The number of things you could type in there is practically infinite. You could never test every single possibility. So good testing isn't about testing everything. It's about being smart and using risk analysis to focus your effort where it matters most. Principle number 3 is a big one. Test early. Finding a problem when it's just an idea on a whiteboard costs almost nothing to fix. Finding that exact same problem after the software has shipped to millions of people, that can cost a fortune. The earlier you find it, the exponentially cheaper it is to fix. And here's a fun one. Defects cluster together. It turns out bugs aren't spread out evenly through the code. They tend to hang out in groups, usually in the most complex parts of the software. It's like the 80-20 rule. So when a good tester finds one bug, they know to start looking for its friends nearby. Okay, principle 5 is called the pesticide paradox, and it's a perfect analogy. If you keep spraying the same pesticide on a field, the bugs eventually become immune. Well, it's the same with software tests. If you run the exact same tests over and over, they'll stop being effective at finding new bugs. Your tests have to evolve. Number 6 might seem like common sense, but it's crucial. Testing depends on the context. How you test a simple mobile game is going to be completely different from how you test the software that runs an airplane. The risks, the goals, the technology, the context changes everything. And finally, number 7, the absence of errors fallacy. This is a huge trap. You can spend all your time finding and fixing every single bug, making the software technically perfect. But if that software doesn't actually solve the user's problem or is a pain to use, then it's a failure. Building the wrong thing perfectly is completely useless. So, with all those principles in mind, how does it all come together in the real world? Well, it's not guesswork. It's a very structured process that takes you all the way from an initial idea to a final verdict. The whole thing flows through these key stages. It starts with planning, setting the strategy. Then you get into analysis and design, where you figure out what to test and how. In implementation, you actually build the test cases. Then comes the main event, execution, where you actually run the tests and see what happens. And you wrap it all up with completion, reporting the results and giving your professional opinion on the quality. And throughout that whole process, testers are creating all sorts of documents. We have a name for all that stuff, testware. Just like hardware or software, testware is the collection of things you produce. Test plans, test cases, bug reports, these are the tangible results of all that hard work. Which brings us to our last section, and it's a really important one. Who's actually responsible for all this? The answer might not be what you think. See, in modern software teams, we've moved on from the idea that quality is just the tester's problem. Now it's all about the whole team approach. This means developers, testers, designers, everyone. They all share responsibility for quality, right from day one. Quality gets baked into the product, not just inspected at the end. But even though everyone's involved, professional testers bring a unique set of skills to the table. That deep analytical thinking, a genuine curiosity for finding the breaking points, and of course the communication skills to explain really complex problems in a simple way. So after all of that, what's the bottom line? What's the point of all these plans and principles and processes? It all comes down to one word: confidence. Every single thing a tester does is about providing information to help the team, the stakeholders, everyone feel confident that this software is ready to go out into the world. And that's the thought I want to leave you with. Testing is the bedrock of our trust in the digital world. It gives us the confidence to do our banking online, to get on a plane, to trust a medical device. So, what happens to our world when that confidence is broken? That's something to think about.